Hello my dear little friends, I'm back again. In the previous video, we learned the definition of force, we learned the effects of force too, we learned that two objects may or may not have in contact with each other, they may be kept at a distance, even then they can apply force on each other. Let us have a glance on some parts of the previous video. You can watch that video if you have not watched till now by tapping the icon above, or else you can use the link of the video too. I have given the link in the description box below. I mean to say that there is an interaction between two objects. We can conclude that a force can stop an object in motion. Before finishing off, let me remind you that we have taken two objects in a direct contact in this video. We will be talking about two objects interacting from a distance in the next video. However, force can be applied by an object to the other even if they are kept at a distance. Let us verify this with the help of some examples. You know that an object falls from a height. You know that this happens as the earth pulls the object towards its center. Look at this clip. The ball is falling from a height. It is happening as the earth is pulling it downwards. You know that the name of this force is gravitational force. Tell me, have you ever seen the earth in contact with the object to apply that force on it to make it fall from a height? No. Look at this. You know this is a magnet. There are some paper clips here. It is not surprising to you that the magnet attracts the clips. It is attracting. This incident is quite normal to you. You can say that a magnetic force is acting on the clips. But tell me, does the magnet need to come in contact with the clips to attract them? No. I have taken another magnet. Look, magnets can repel another magnet for certain reason. We will learn this property of magnet in another chapter. However, repulsion is a pushing force. Here, one magnet is applying pushing force on the other, but from a distance. They do not need to come in contact with each other. What is this? This is a plastic ruler. There are some tiny bits of paper. Look, I am rubbing the ruler against my hair. You know what I am going to do next? Yes, I am going to take the ruler close to the pieces of paper. What is happening? Papers are attracted by the ruler. Is this a magic? No, not at all, but it happens. Some of you must have done this unknowingly, but it happens. But why does it happen? It happens as some electrical charges concentrate on the surface of the ruler. On which surface? On the surface that has been rubbed against my hair. This surface. You may call this electrostatic force. Tell me, have I taken the ruler to touch the papers to attract them? No. Therefore, we can conclude that an object may have impact on the other even they are kept at a distance. This force which acts from a distance is called non-contact force. So we can classify forces into two types: contact force, what we have learned in the previous video, and non-contact force, just we have learned in this video. But we shall analyze some examples of contact force in a more intense way. One interesting thing is awaiting us. Let us try to find some other examples of contact force. For that reason, a pair of scissors is cutting a piece of cloth. The blades are applying force on the piece of cloth. Also, the person using the scissors is applying force on the blades by his fingers or by his hand. He is also applying force. In this clip, the blades are in contact with the cloth. The hand or the fingers of the user is or are in contact with the blades. In this clip, a screwdriver is inserting a screw. This is another example of simple machine. Here, the screwdriver is in contact with the screw to apply force on it. Also, hands of the user which are in contact with the screwdriver are applying force on the tool. In this clip, a wrench is another example. In all these clips, I have taken the examples of some simple machines, as we will learn simple machines very soon. However, apart from the examples taken in this video, many more can be noticed around us. In almost all the examples, two objects are in contact with each other when one of them applies force on the other. Now, let us move on to some different type of example. Look at this clip. I am pushing this box. The box is stopping after covering a certain distance, irrespective of how hard I push. We have learned that a force is needed to stop the object. Here in this example, the only force we can observe is my pushing force. Nobody else is touching or applying any force on the box to stop it. Yes, nobody else is there. But something else is there. What is that something? Look carefully. The box is in contact with the floor. So definitely the floor is applying a force on the surface of the box in contact with the floor. Therefore, the force applied by the floor is another example of contact force. This force is resisting the movement of the box. This resistive force is called the frictional force. In this context, we must remember the direction of the frictional force is in the opposite direction to the motion, or else the moving object would never stop. It resists the movement. We experience this force in many activities in our day-to-day life. Walking through the ground, writing by pen, holding objects by fingers, inserting nails into any object, etc., etc. are few of the simplest examples that we notice all the time. Now we shall observe two interesting things. Look at this video clip. I am pushing the box gently through the floor of my room. This box is empty. The floor you can see is quite rough. You can watch how far the box moves. Now look at this video clip. This white surface is the surface of a whiteboard. You can see that the surface of the whiteboard is much smoother than that of the floor. Watch the amount of movement of the same box through the surface of the whiteboard. The same gentle push makes the box move through a longer distance. Let us have a look at these graphics to clear this conception. If we would observe a surface by a magnifying glass, we would see that surface which is rough, has many ups and downs, unevenness, in the form of these types of grooves and ridges, like these. Whereas the smooth surface has much less unevenness, like this. So, hopefully you understand now. If one object with little more roughness tries to move through another rough surface, those grooves and ridges get caught with one another and the movement gets disturbed. The amount of this disturbance is very less in case of a smooth surface. So we can conclude that friction depends upon the nature of the surface. Now I am filling the box with some objects available right now. I am actually increasing its mass. Now again I am pushing the box with almost same amount of force as earlier to make it move through the board. See the amount of movement, right? Now the distance covered by the box is less. So we can conclude that friction depends upon the weight of an object. Therefore, the two factors that influence magnitude of friction are the roughness of the surfaces in contact and the weight of the object. But friction does not depend upon the area of the surface in contact. Let me change the surface of the box. I will experience the same amount of resistive force to push or pull the box. We will try to learn the types of friction and few more things, but not in this video. This is all for the day. Now goodbye my friends, for you and I will meet again. See you soon.